in question 2, we're going to be looking at temporal difference learning. So part 1 of this question is asking us to update this Q table that they've given us right here. We need to update it to be after one iteration of the off-policy method Q learning. So in your lectures, I think you guys learned about 2 types of temporal difference learning. One was Q learning and one was SARSA. And you can see that the Q learning one is off policy and SARSA is on policy. So just before we begin the question, I thought we might go and have a look and just talk a little bit about that. So on the screen here, we've got the 2 update rules. The first one for SARSA and then one for Q learning. And you can see there's really only 2 differences between these equations. It's this bit here. So for the Q learning, we've got this max operation, and you can see that it's being applied to the Q value of state t+1. This maximum operation here, you can think of it as looking into the future in one step and selecting the best possible action in that next state, depending on what the Q values are in your Q table. In contrast, the SARSA method, you see it doesn't have this max operation here. Its Q value, that's one step in the future, it's just got st+1, which is the state in the next time step, and it's simply got at+1. There's no max operation for it. This just means that the action for that next state is going to be chosen according to some policy that the agent is using. This max operation, this means that for the Q learning, the agent is selecting actions not based off some policy that it's got. It's literally just looking at all of its options and choosing the one that gives it the best Q value. So in this way, the Q learning is kind of separating out its behavioral policy, which is the way that it selects actions, from the actual policy that it's trying to learn, which is like the overall optimal way to navigate the environment. So yeah, just remember the difference between these 2. On policy means that in this update, as we're updating our Q values, you're going to be using a Q value that relates to a state and an action that, an action that's determined by some policy that the agent's got. Whereas in the Q learning, it's just going to ignore whatever policy it's got and just select the best at every possible opportunity, whatever it's the best Q value it can get. So that's kind of a little bit about the off policy, on policy thing. But when it gets down to doing like answering the actual question, it's kind of just a mechanical process. So what they say in the text description up here is that we've got an agent which is in state 1, and we're currently updating the Q value for action A1. So we're focusing in on this part of the table. We want to do one more iteration, just like we did in question 1 when we were doing the Q table iterations. We want to do one iteration and update this value here. So I'm going to go over to the whiteboard and set up our Q table. So we've got Q, state 1, state 2, action 1, and action 2. And just like in question 1, we want to update this table. So since part 1 is using Q learning, I'm going to go back to the lecture slides and get the update rule. just for simplicity, I'm going to call this x down here. So x equals, and if we look over here, we've got q st at. This is the current estimate of our state action pair, 0.15. Just like we did before, we need to add some adjustment to get our new estimate. And if we look at the equation over here, the first thing is alpha, which is our learning rate. And back on the tutorial, that was 0.3, they told us. Inside the brackets, the first thing we see here is RT plus 1. This is the reward that the agent gets for taking the current action. So let's jump back over here again. We know that we're updating this square here. So what's happening is that we're forcing the agent to take action A1 from state 1. And if you recall back to the picture of the world that we drew, this is the self loop that we had in state 1, which begins in state 1 and then ends in state 1. The reward for that one was 0. So we put in our 0 reward. That's RT plus 1. And then we've got gamma and then the max operation that we were talking about a moment ago. So our gamma value in this question is still 0.9. So I'll put 0.9. And then we're going to multiply it by the best possible action we can take in the next state. So what is the next state that we're talking about? Well, because we're over here updating this one, we're being forced to take action A1. That means we end up back in S1. So to get the best move in like the next state, we have to look along this row here and choose our best option. So obviously we get our maximum Q value if we take action A2, and the value of it is 3.55. So we put that over here, back to the equation, and the final bit is an adjustment for the current estimate. So let's put minus 0.15. Now if we reduce this all the way down to get our actual new estimate, I'll just need to do a bit of calculation. Get that. 3.195 minus 0.15 gives us 3.045 times the learning rate, 0.3. We end up with 0.9135. So we put that over here. And our final result ends up being 1.0635. So that's basically our new estimate for this state action pair. So a Q table after this iteration is going to look like this. .06, and then none of the other ones change. Keep them the same.